So let's have a look on the block plans now, what pressurisation means. I mean, it's very, what we're doing in fact is supplying air into the stairs, directly into the stairs, to pressurise the staircase. And if we raise the pressure in the staircase to 50 pascals, then no smoke is going to get in that staircase at all, independent of whatever happens. That's positive and concrete. And that is doing no more and no less than any of the other systems, but it's doing it more reliably. Some of that air will escape the building. Am I all right walking about, cameraman? Yeah. Will escape the building via the fire floor, and in so doing will provide a degree of pressurisation and protection to the lobby. If that lobby is what we call a simple lobby with no lifts and toilets in it, and the two doors in and out are equal, the pressure in that lobby will eventually reach about 45 pascals. So once again, we are providing a little bit of protection to the lobby itself. But we can go farther than that with pressurisation, I believe. That if I can go some way towards protecting the lobby and corridors. Obviously, if I take the stair lobby door away, then the lobby is pressurised from the stairs, and I've got full protection. Now, man, I want to do that, but it just struck me that the saving on the number of doors might help pay for the pressurisation system. But if I then arrange for the lobby to corridor door to open in the event of a fire on that level, then I can arrange to pressurise the corridor to my 10 and 15 pascals. Obviously, that will then feed back, and the pressurisation system will then be producing 10 to 15 pascals all the way down the stairs. But in buildings of 50 metres high, that's enough anyway. And in that way, I can actually, by pressurising the corridor in that way, I can protect the corridor so people can come out of the 20 or 30 flats along that corridor into a clean area and get out of the building. And I can do that in two ways. In the way I've described, by extending the system blowing into the stairs to run into the corridors, or indeed by leaving that door closed and pressurising the corridor separately from the end of the building. That's a bit more complicated, but it is a way of doing it. What you notice from that, of course, is I have no vertical smoke shafts. I don't have any vertical smoke shafts. I'm using the stairwell as a vertical smoke. But it's not a smoke shaft because there's no smoke there. And by that route, pressurisation can be applied very simply to existing high-rise buildings. Thanks. And what I've persuaded Flackwoods and my friends at Interactive and FEA to do is to put together a package of fans and vents and control gear to do just that. This thing here would fit on the top of the stairwell, or indeed on the side of the stairwell, and introduce air and pressurise the stairwell. It's a complete system, both roof and window mounting. The whole exercise is a complete system, including design and installation, commissioning, in line with the European standard, and the fan in it, we have fitted in. I've persuaded them to fit in there a high temperature fan so that I can use it for both pressurisation and for ventilation. Because obviously, if I'm passing hot smoke through it, it needs to be able to survive those temperatures. And so the thing will deal with both methods of powered smoke control in high-rise buildings. And the most important thing is that smoke shafts are put there, not always required, because if I put a duct down the end of the corridors to feed air in, that's going to be a smoke shaft of sorts, but it won't be a right big one. Now we've got the video. Just a word about this video. This video will show you a test of a system like this, carried out in Helsinki under the guidance of the Helsinki Fire Brigade. And there's a couple of things about it I need to tell you, is that the Finns called their system Smoke Master, and you'll see that on the video. It is designed for the Finnish climate, where it snows a bit more than what it does here, and it is shown operating in both modes, both as a pressurisation system and as an extract system. And the man who's actually headed that up in Finland is actually sat here with us this morning.
Laskut, sä oot luvannut sen.
There's so much smoke in here, we can't get out. That headline appeared in the Mail on Sunday on the 5th of July 2009. They were the last words spoken on her mobile telephone by a lady, resident of one of the flats in Lakener House, speaking to her friend outside the building. Both her and her 3 children died probably of smoke inhalation. We can and must do better. And I believe that simple pressurisation systems might lead, fitted into existing buildings, might lead the way forward. They've tried it in Finland. Will somebody please in the UK do the same? If you're at all inclined to do that, please come and talk to any of us after the, during the session. Thank you very, very much for your attention. Thank you.